Welcome, everyone. This is AI Ascendant. If you're in the wrong room, please leave now before the plane leaves. My name's Steve Lohr. I'm a technology reporter for the New York Times. I'm moderating the panel. And my job is to introduce the panel members and set the table a bit. I'm told this will last an hour and 15 minutes. And we've allowed 20 minutes at the end for questions. If you'd like to send them in by the app, that's great. Otherwise, even better, stand up to the microphones. This isn't that big a group. So, but let me start with the introductions with, on my far right, Tom Dietterich, who is the president of the Association for the Advancement of Artificial Intelligence. Tom's a professor at the Oregon State University's pioneer in the field of machine learning, its essence, its methods, even applying it into various realms, including the environment recently. He's working with computational sustainability. And of course, I assume everyone who's here heard his excellent lecture this morning, and you know, autonomy is Tom's line in the sand, which I'm sure he will elaborate. To his left is Hadas Kress-Gazit, and she's a robot tamer at Cornell University, and she heads the Verifiable Robotics Research Group, focusing on communications and controls. The communications kind of things are converting high-level searches, high-level commands like search the rooms, as opposed to having to say, you know, proceed 7 steps, turn right 30 degrees. So it's that kind of high-level translation. And then the controls to make sure these things, as much as humanly possible, actually do what they're supposed to do. To my left is Yolanda Gill, who's a professor and scientist at the University of Southern California's Information Sciences Institute. Knowledge capture and intelligence systems are 2 of her areas of expertise, and she was nice enough to invite me to dinner last night with a group. And if you have also questions about travel in Spain, that's another area of her expertise. But using AI techniques in support of data-intensive science is a real focus of hers, as well as trust and provenance. And I love the name provenance with the art history connotations that it has. But this involves following the automated decisions that these systems make back to the heritage of the data itself. And she initiated and chaired the World Wide Web Consortium's Provenance Working Group. And on the far left is Trevor Darrell, University of Berkeley, UC Berkeley professor. He's a computer vision and deep learning guy. Robots and other vehicles are among the applications he's worked on, including a vision to give robots better hand-eye coordination. And his, again, from talking to him, his path toward robotics is a little bit less than the machines that stare you in the face, but more ones that focus on sort of discrete things. And the thing he particularly liked to do is have a robot that cleans up his backyard and his deck. Now, I thought I'd start with just a little bit of perspective. This is something, a few sentences that were written by prominent computer scientists. In designing software and microprocessors, I never had the feeling that I was designing an intelligent machine. But now, a new idea suggests itself, that I may be working to create tools which will enable the construction of the technology that may replace our species. How do I feel about this? Very uncomfortable. This is written, the writer is Bill Joy of Berkeley Unix and Sun Microsystems fame in an 11,000-word essay entitled Why the Future Doesn't Need Us. It was published in Wired magazine in April of 2000. So these, the concerns of the Stephen Hawkings, the Bill Gates, the Elon Musks of summoning the demon are not new. But the context changes. And by way of levels, there's a great debate about whether the trajectory and the pace of these technologies and the implications of it. And I thought, as a kind of a level-setting starting point, I would ask each of our panelists to describe what in their area of research would constitute a really big win over the next 5 years, 10, whatever you choose. And then what would be the practical implications of that? What kinds of things would that sort of breakthrough open the door to? And let's start on the other end with Trevor.
Great. Well, I'm going to actually mention 2 things. One kind of in the nearer term, focusing on computer vision, and one slightly farther out, focusing on vision and robotics. And in the near term, I think we can see methods that are based on the current successes of machine learning and big data and deep learning, methods that can really extract semantics from media and signals and images and video, where now we can do very coarse tagging. You know, you can kind of pick out the main objects in a scene, maybe provide a caption that's a gloss of an image. But I think what we'll see in the next 3 to 5 years is a real ability to do rich description and visual question answering. So I can take an image and I can really tell you everything that's going on. There's 4 people, they're having coffee, there's a panel, there's 2 glasses of water on the table. What color is the tie on the man sitting to the left in this image? And have algorithms that can solve those tasks with a pretty good level of competence, at least, close to some human's performance, something like that. And I think that will have a lot of applications, from organizing your own media to searching for events of interest in videos and so on and so forth. And the slightly farther out is how this connects to action in the real world. Collaborating with roboticists at Berkeley and elsewhere, we're very excited about taking these methods that can learn very effective perceptual representations to do those tasks that I just mentioned, but then connecting it all the way to robotics, which I think is and other domains of AI, robotics, language, haptics, et cetera. And I think creating that fusion, which is sort of the grand challenge of AI, bringing together these abilities, which many of us study separately, but I think studying them together and having representations that can be learned for them simultaneously, building something that can have a reaction loop between what it sees in the camera and what it feels in a sensor, and then what it does in the real world. We're really retackling that level, that kind of model in our work, and I think in the next 5 years we'll see much more agile and reactive, both small little robots and larger robotic systems that could, help you in your backyard, or clean up your toys, or help you cook in your kitchen.
Great. Yolanda?
So I've been interested in using AI to assist scientists to be more efficient, to be more thorough with their work. We've been developing intelligent workflow systems for data analysis. And what they do is they actually understand a bit about the data and a bit about the data analysis algorithms. And so they help scientists configure the workflow so that the data analysis is correct and respects the constraints of the algorithms and the data. And we're moving towards an area where we can actually do or develop an intelligent scientist assistant. So last week we started a new project funded by DARPA where we are looking into the processes that a scientist goes through in analyzing data over time. So a new algorithm becomes available next month, you should be running again your data analysis to see if that new algorithm changes the results in some way. Or maybe new data becomes available, can you look again and see if you have new findings or find new patterns? So we're looking into these intelligent scientist assistants. Longer term, what I see is that AI will be very, very necessary to help scientists face the grand challenges that they want to solve in the next few years. So whether in medicine or environmental or other challenges. What I see is that scientists have become very specialized in their own field. So they have very few means to make connections across fields. So for example, if you're a hydrologist, you study rivers. If you're a limnologist, you study lakes. And those two fields rarely talk to each other. They have a completely different vocabulary, completely different sets of data, completely different models. And scientists have a really hard time connecting across fields. This becomes an exponential number of connections. So I think that AI has a lot that it can contribute in helping scientists connect across different areas. So making analysis by exploiting knowledge that we can add on top of our current systems that will enable AI systems to help them make those connections. So for example, I work with a group of researchers that are trying to understand the age of water in an ecosystem. This is very important to understand the carbon cycle. And because they belong to different disciplines, you study fish, you study the algae, you study the vegetation, you study the river, you study the lake. Everyone has a completely different set of assumptions and models. A lot of the AI techniques, knowledge representation and reasoning, can help them map across the different areas of expertise that they have. And so to solve these big problems of environmental research, urban ecosystems, biology and medicine, all these very integrative challenges that we face in science, I think that we're going to need strong AI systems to help scientists make those connections.
Thank you. Hadas? Dietterich?
So I'm a roboticist, and what I'm interested is in high-level behaviors for robots, so being able to interact with robots at a very high level and have them do the right thing, have them not fail, have them degrade gracefully, and all those things. And what we saw, especially a recent example is the DARPA Robotics Challenge, is that we have made a lot of progress in the last few years, and kind of connecting to what Trevor said, in creating components. So we have a good motion planner, or we have a good relatively good perception module. We can map something, we can sense something. But putting everything together is still very, very challenging and error prone, and basically it boils down to a few very smart people sitting down and writing code and testing as much as they can to see if it works. So what I would like to see, and what I think would be a big game changer in the next 5 to X years, is if we are able to create these components, but components that have either perception or actuation, but they also have some notion of guarantees, some notion of a way to quantify under what conditions, under what situations they would work well, either probabilistically or deterministically. Under these set of conditions, it will not work. Under these set of conditions, yes, it definitely will work. Everything else in between is kind of fuzzy, we're not sure. And then using those components and that knowledge about the guarantees of these components to compose them in a way that's correct, in a way that you can provide guarantees over the composition, and then have these systems that anybody can program. So now you pick and place, or you pick and choose, not pick and place, pick and choose different components that you want your robot to have, and you say, you know what, go search the rooms, or go clean my backyard, or go make coffee, and the robot will do that if it's possible. And if there's something around the environment, because these are physical systems, they will not always succeed. But to make the real impact is to have the robot that comes back and tells you, you know what, I can't do this because I can't guarantee anything about this, because my sensors are dirty, because the door is closed, because we ran out of coffee and I can't go to the store. Once you have these systems that are able to interact with the humans that are working with them, and explain why things can and cannot be done, then we can see these systems a lot more in everyday life. I mean, imagine a self-driving car that tells you, you know what, you need to take over because it's starting to snow, and my localization and my sensing just degrades horribly in snow. So things like that.
So it will be able to open the door. I mean, this was the DARPA challenge on it, as Rodney Brooks had pointed out, is if you fear the Terminator, just close the door. Yeah.
Just to be fair, almost all teams open the door. So
eventually.
Within an hour.
And they weren't autonomous, right? I mean,
it was different teams had different levels of autonomy, but none of them were fully autonomous. Yeah.
So I guess I will also talk about two things. So to begin with one that's most closely linked to what Hadas was just saying, one of the areas that I've been working in is anomaly detection. And I have many interests in that area that have to do with, for example, detecting broken sensors in the Internet of Things, or detecting in computer security settings insiders who are doing something unusual in a company, or advanced persistent threats in a computer network, things of this sort. So in advance, something that would really let us move forward would be to have a good theory of anomaly detection and how much can really be achieved with it. Because I think artificial intelligence I sort of depict as going through 3 phases that were articulated by a previous Secretary of Defense. The period of the known knowns, which was in the 1960s and early 70s, when we studied things like chess and checkers. where you can see everything and the world is deterministic, it obeys beautiful laws, and we can execute perfectly. Then starting in the 80s, we adopted the known unknowns, which is to say we would model things that we were uncertain about as random variables, and we adopted all of the formalism and maybe even contributed to probability and probabilistic reasoning. But now the challenge with our systems is to make them robust to the unknown unknowns. So what are the things we forgot to include in our model of our robot and its capabilities? The surprising side effects, or maybe the things that some adversary has done that have make our model no longer correct. And so I'm placing bets that anomaly detection would be one of the things that would allow us to do that, because a computer system could detect that it's in a situation it's never been in before, and maybe it doesn't know that there is snow. Of course, our friends at Google and so on and Tesla are worrying about snow, but suppose there was some new form of precipitation that they hadn't seen before, a dust storm that they had never trained on. How could the system say, oh, you know, the vehicle is no longer behaving the way I expect it to, you need to take over. The other thing that I've been working on a lot are problems, problems I wish I could solve involve spatial planning. And I'm not really talking so much about how you lay out your refrigerator, but more problems of, say, how you manage wildfires in the forests in the West. If you can pay people to go in and remove accumulated fuel and so forth, where should they do that? Or invasive species, or if you're managing a traffic network or a power network or the water network, where should you add capacity and so on? And these are extremely difficult problems, and we really don't have any good solutions. Most of our solutions are very heuristic, particularly if the systems operate with a lot of uncertainty, stochasticity, and so on. And when you have many objectives, like you want to minimize the cost of firefighting, but you want to minimize the number of houses that get burned down, you want to maximize invasive species habitat, and you want to continue supporting the timber industry. This is a big issue in Oregon right now. So if we had a breakthrough that could somehow allow us to solve these spatial planning problems tractably, that would be wonderful. But right now, we divide up space into thousands of management units, and you can do, say, 5 things in each management unit. You have a huge exponential explosion of possibilities to consider, and we don't really have any good ways of solving those problems.
Thank you. Well, the subtitle for this workshop is Designing AIs to Do the Right Thing. Well, it's loaded as to what one thinks is the right thing or not. But in this, in this sort of policy realm, one of the things I wanted to push on a little bit starting with Tom actually, but is this notion of autonomy that you picked up before, and this distinction between AI tools versus AI autonomy. And my question is whether the distinction is really as clean as perhaps that might suggest. That is to say, as the tools get better, we rely on them more and more. And they sort of shape the kinds of decisions that people, as the monitor at the end, again, it relies on them more and more, and you kind of go with it. And the human kind of gives up effective control in that scenario. And the clever helper, the benevolent assistant, which is the way it's always cast, takes over. And I think of, this sort of, the movie dystopia of this is, not the Terminator, but WALL-E. The Pixar 2008 movie where, they gave up their physical abilities, but everything else as well, because things work perfectly well on their own. And one of the questioners this morning kind of touched on that point. Mm-hmm. It's certainly a useful framework, man in the loop. But as these tools get better and better, doesn't the line kind of blur in terms of trusting him too much?
Well, I think maybe a useful place to start is who would be legally responsible for an action, or who is morally responsible for the action. And right now, I don't think anybody can sue Siri. Right. In fact, Siri doesn't really take any actions in the physical world. The biggest thing she can do on my phone, at least, is set an alarm or create an appointment. So one of the things I thought Bill Gates said when he really put his finger on it was, computers with resources are dangerous. And because if a computer has a lot of money, for instance, then they could start getting online and buying things. Maybe they could arrange a big traffic jam just by ordering a bunch of taxi cabs to all come to the same address, or things like this. So I mean, this is not so much that the AI would spontaneously do this, but perhaps an adversary who got control of the system could use it as an action at a distance kind of thing. So whenever we write a computer program, it executes autonomously in some way. But as long as it's taking actions only in its sort of internal memory, and its scope of autonomy is very small. And I can always hit Control-C for the Unix people in the room, or Control-Alt-Delete, or whatever it is on the Mac, the Clover, force quit. And the only damage that's been done is to some information, maybe. So I guess my operational definition of the autonomy would be, when does it take actions over a long time span that would involve the physical world or resources, valuable resources that I want control over? So it really is a kind of gradations. Now, but you're asking a different question, which is kind of, do we become psychologically or cognitively reliant on our tools? Well, of course we do. I mean, I think I'm smarter with Google in my hand. But wait a second, I'm getting a call right now. But the problem of attention control is now become probably the #1 critical issue. And I think, our children and our children's children will succeed only to the extent that they can control their attention and not be distracted by all the distractions that are out there. So
yeah, well, I guess Herb Chase is a bioinformaticist now, actually, at Columbia Medical School, and he was the dean at Yale for a decade, and he tried out one of the Watson Health applied science projects, right? And he said, well, look, 30 years ago there was this case we could never figure out, but I lucked out in the end and we got it. And so the diagnosis was adult rickets, so he threw those symptoms into the Watson Health software, and he figured, I'll get the damn machine now. It'll never get this, right? And the way this machine works is it gives you 3 priorities of what the diagnosis was. It shows you the top 3. The second was the adult rickets, right? And his concern is exactly the one I stated, that as this goes forward, that and maybe it's nostalgia, right? I mean, maybe he's a guy about my age. This is not the way it was done, right? I mean, you can argue in all of these cases that on average, these things do, it's much better than it used to be. So he may be wrong, but I sense this, moving toward boiling the human frog. With these technologies, little by little, not a catastrophic event, but just kind of get it. And maybe that's progress, right? I mean,
but right. Certainly, if you're a utilitarian, to come back to the discussion this morning, there are a lot of these applications where the computer would be better than the 90th percentile doctor, right. And so. But probably there is some 99th percentile doctor out there who's better, and so you have this very American trade-off, which says we're going to do well uniformly across the population, even though we may lose at the high end.
Well, does everybody agree with? I mean, you think there's going to be autonomous machines at some level someday, right?
Yeah.
Yolanda? Well, just and up to a point, Lord Copper. I mean, they're going to be able to but contained. And you have again, Tom raised the issue about law, and legal rules and stuff. So I mean, elaborate a little bit on what you see.
So I agree with what Tom said this morning, which is that we'll get there gradually. It's not like someday there's going to be this autonomous set of machines. We'll get there gradually, and we have many machines that are actually making decisions for us. So in my house, there's something that changes the thermostat target temperature just by itself, and I live with that. So that kind of machine will get more and more intelligent over time. So I guess you're asking me about the legal framework. I think this is very important and something that we haven't thought very much about. So to me, when you start to have autonomy or machines that can make decisions and are using complex intelligent capabilities to make decisions, we have to start to think about accountability. and we have to think about a legal framework for that. So we have to start entering the realm of the law and a legal framework for these machines to inhabit. We don't have anything like that right now, so we have to think about, when my children get into trouble, I'm kind of accountable for that. When my dog does something to somebody else, I'm accountable for that to some degree. And there's consequences for that accountability. So we should be inhabiting a world where the intelligent machines that we're going to be incrementally see come out have some responsibility or accountability, and they are there's consequences to that accountability. So if I deploy a sensor in my house and there's a pet in the house and they die because I set up the sensor in a certain way and they get asphyxiated, am I responsible? So we need to define those responsibilities and those levels of accountability. When we have that, then I think the autonomy of the machines comes into play. So the machine will be autonomous, but is there someone who is responsible to override that autonomy? Is there someone who is responsible for having given the machine a certain amount of autonomy? So we are technologists and we develop intelligent machines. We're not legal scholars. So I think the talk that Tom gave this morning, followed by someone talking about the law and the ethical implications of the machines, those are two sides that we need to really put together and explore. The legal framework is very important to the autonomy of the machines, I think.
Is there, go ahead, Trevor,
mean,
because you've talked about the thermostat.
I'm just curious, I think we already have a legal framework for, automatic transmissions and anti-lock brake systems, and and thermostats in homes. So I wonder whether we already have some of this. Probably we don't yet have the case of the autonomous social robot that slanders somebody else, and whether who gets sued for that. But I mean, I think the lawyers may be able to figure this out for us if somehow we have autopilots and all of this. When I think of wanting and in terms of the giving up our human skills as we delegate to other agents or assistants, just the historical note that I'll make on this point is the earliest example that I've heard of this was, and I forget the name of which philosopher debating another philosopher, bemoaning the lack of the oral tradition when writing was invented.
Yeah.
Okay,
Sure.
so obviously we became much worse oral storytellers when we all started to read. And if we didn't read, we'd be much better at storytelling.
That's the nostalgia part.
We give up that, and I'm sure we'll give up other things, and there are very, many talents like digging ditches are lost when the steam shovel comes, and so on and so forth. So how we not get all the way to WALL-E, I hope there will always be challenges in intellectual stimulation that humans find for each other, whether they're for real work or just for fun. But I hope that's the answer there.
I mean, I'm wondering if on your kind of your law and kind of implicitly policy point, whether there's any analogy, because the discussion here, as to some degree we're talking about, and earlier this morning on genetics was about, that was about preemptive movements. And any important technology always has trade-offs, and the response is always some combination of rules and tools. I mean, the automobile, kills people, pollutes the air. It's also a vehicle of individual freedom, mobility, open the way to national and regional markets and so forth. And we kind of, in most of these technologies, regimes are set up, but after you sort of see what you can do. I mean, there's an implicit, assumption in some of these things, and Kevin Bostock, the guy who did, who's ginned up Elon Musk and Hawking and so forth, is that it's different in this context, and we should do things in advance. And I'm wondering if there's an analogy here. Have we ever done things in advance from a kind of controls regulatory standpoint? Although, Tom, I mean, this, the genetic side of it, kind of.
That's one example.
We've done some of that, I think, in terms of catastrophic constraints, right?
Mm-hmm. Right. And actually, we had a meeting also at Asilomar of the first group that Eric Horvitz convened when he was president of the AAAI on long-term futures of artificial intelligence. And we didn't come to any consensus about whether there were certain experiments that should not be done.
Right.
But I think it might be time for another such meeting to think about some experiments that would be very risky to do. And maybe they're not imminent. I don't think that, right, that we're not facing the urgency isn't there right now. But I would advocate that there would be some experiments that would be very dangerous, and perhaps we shouldn't be doing them.
Let's give us one or two.
Well, I guess if you did allow, if let's say we built robot weapon systems that could operate for long periods of time without any human in the loop or any human intervention, I think that'd be very dangerous. So experiments along that line might be very dangerous. The biggest risk, though, I think, is if we ever had systems that could reproduce, right? And so perhaps if we assembled 10,000 3D printers and wrote some sort of genetic algorithm to experiment with developing new devices and measuring their, I don't know, killing potential or something like this, that might be a very dangerous thing too. I mean, a similar and more dangerous experiment today would be to assemble 10,000 DNA synthesis machines, have them all insert things into viruses and see which ones went and killed humanity. And that's definitely an experiment that we should not try.
A little bit of knocking down a straw man, but good example.
Well, but that is, I mean, and that is the autonomous system that is most dangerous right now today, because it can self-reproduce, it can self-modify, and so we have those two things which our AI systems right now are not able to do.
I mean, regardless of the trajectory of the pace, I mean, the development of these technologies, what actually worries you? Hadas?
Actually worries me.
Yeah.
Good question. So I'm a very pragmatic person. So the whole robots are going to take over the world and kill us. It doesn't seem like an imminent problem right now. Again, what Tom was saying and what Yolanda was saying, that this is gradual, and these things are going to gradually enter our lives. Kind of following up kind of what you just said about the experiments, and I'm not saying, I want to go build a system that now I'm going to experiment with it killing everybody, but we need to be careful that fear, and especially things that are not necessarily fact-based fear, do not restrict the progress and the things the good things that can happen from these technologies. Robotics and prosthesis and all these things can be misused horribly. But does that mean that we should not develop these technologies? Does that mean that we should, kill the funding? That means that there should be, very strict controlling of what those types of research? That scares me in the direction of progress. That doesn't scare me in the direction of we're going to create technology that will doom us. So, but again, these are discussions that are important and they need to happen, but they have to happen. In a way that's informed, in a way that's fact-based, in a way that we understand exactly what can and cannot be done, and I guess.
Trevor, you want to take the same question?
What scares me?
Yeah.
I probably would err to the same direction. I might be scared by if we all become ignorant and put our heads in the sand about not doing lots of interesting things. I'd also be scared if we avoided discussing these issues. I mean, I'm really all for raising the rhetorical level, and I think this sort of ethical discussion is one that is very important. And as I think I've just said, I think you can actually do it from a historical perspective of why many of these. I don't think this is an entirely new discussion, and we should we shouldn't avoid it. I do think that the things that we're scared about, the impact of some, and I agree with Tom's earlier point that I personally don't think it's a threshold event. In his talk, he was commenting it's not a threshold event. We're not going to suddenly have all the AIs turn on. Maybe we are slowly getting somewhere like the boiling frog, which we should worry about. if you are worried about that, I personally don't think it'll happen in my kid's lifetime. But if you're worried about some large set of autonomous programs running amok, messing with our world, or creating, suddenly making all of the autonomous cars in the world, taking control of them and simultaneously driving them into a ditch, I mean, we should be worried about that, but we should be worried about semi-autonomous networks of computers and humans also who are wanting to do evil things to us doing that. And we already have that today. So we should be building defenses into our infrastructure just to make them more resilient to natural disasters, networks of hackers, and networks of hackers with large amounts of computational abilities. And I think that's the best thing we can do to defend ourselves against the alien invasion or the AI Ascendant overlords.
Yolanda?
If I fear anything, I fear humans more than machines. So my worry is that we'll have constraints on the kind of research and technology that we can develop. So we've seen those things with stem cell research, for example. So I worry about those fears causing limitations on what we can work on, because it would cause a lot of missed opportunities. So we just held a workshop at the National Science Foundation with AI researchers and geoscientists to recognize the need for geosciences challenges to incorporate AI technology. And what's interesting is that the geoscientists describe their problems, and when they hear the AI researchers saying, oh, we could help with that, we have some techniques that are relevant, and we have capabilities that we could work together to incorporate into your research, they get very excited. And so they can see that they can otherwise not solve those problems. So I have fear of the missed opportunities and of the humans that will cause them rather than the machines.
Mind if I ask a question?
Sure.
So somebody brought up the weapon system example. I would be curious, many people are in agreement that weapon systems maybe shouldn't be fully autonomous and intelligent. But what would happen if another nation state were to pursue those technologies? What kind of edge do you think they would have over a nation state that didn't? And would we all be forced to then pursue those technologies just to be competitive?
Yeah,
I think the answer is and also how do you really define whether a technology is offensive or defensive, and would you want to exclude?
Let's say offensive.
Right, but that same technologies often could be used in both kinds. I think it's very hard to define these things and these boundaries.
Let's say we have an enemy that pursues an offensive technology. How do we respond to that? I mean, would they have a great edge over us in the near future, like in the coming decades?
But the way to counter that is not necessarily build another autonomous weapon. It could be. Did everybody hear the question?
Well, I mean, if you have something, for instance, that responds very quickly, like much faster than human decision making can respond, this sort of thing, it would seem you almost have to have something that's also acting very quickly, kind of like the stock market trading.
Well, and we do have such weapons already that respond to, say, an incoming threat in faster than human decision-making cycle. So
I mean, we already have fully autonomous weapon systems at that level.
Right.
That's what I actually find the debate an interesting one, and I mean, I think I actually do find this issue that's been raised by many of our colleagues, I support it at the level of it's important to discuss this, but how to define, but I would also be very worried about any precise definitions, because nobody can tell the difference. The distinction between offense and defense is very hard to define, and we have autonomous mines, and the politics of that is well known and very complex. And analog braking systems and the Gatling guns and autonomous guns for anti-missile systems are all effectively autonomous. So while I think it's important to always be informed about the debate, I can't see any clear line that I would really want to draw that where at a technical level we could say this is by definition something that we shouldn't have, at least to me.
But I think a lot of us heaved a sigh of relief when we were able to have a stand down of the sort of launch on warning nuclear capabilities, both in the Soviet Union and the US. So if we can arrange to slow things down to a more human decision cycle, it does reduce risk.
But was that an issue of autonomy or just the enormous destructive power of nuclear weapons?
Well, it was the issue of making a very quick decision under very short time constraints, which is almost a forced decision, right?
But you like your automatic brake system, right?
Yes, I do. Yes.
Yeah, not the high-stakes decision, right? The automatic transmission, nobody cares how it works as long as it does.
Well, but my anti-locking
lock
brake
brakes
system, I think, probably saved my life once. So yes,
and if it turns off the brakes, it's turning off the brakes. It seems crazy.
What Danny Hillis's line on this, these systems, if they're going to be, if they're going to work and be acceptable to society, they have to be able to tell that it will come down to storytelling. They have to be able to explain how they made the decision they did. And I think, in some of this, looking at it in that context, I think we're a little bit robotic-centric in the sense that we think, in robots you can see where they succeed and where they fail. And that's fairly easy. Whereas, the applications of these technologies, at least certainly in the commercial world so far, have been about improving the odds of making a sale. Ad targeting and personalized marketing. And now we're moving into realms of using these machine learning and AI techniques for things that matter more, and it's more subtle and it's more software. And a classic example is the whole slew of data science startups around lending, and they're making automated lending decisions based on different sets of data beyond traditional FICO scores, and a huge benefit potentially in that you can save millions of people billions of dollars. But as Rajiv Datte, who is a funder of some of these startups, as well as he was the deputy director of the Consumer Finance Protection Bureau, said, a decision is made about you and you have no idea why. And this touches both sides, your monitoring side and your, making sure it works side. What do these systems have, what can we expect of them so that effective control exists? They have to tell their story, what are the kind of mechanisms by which, you'll be able to see how the decision was made?
Yeah, so you mentioned in the introduction work that we've done on Provenance. So some years ago, I was part of a couple of DARPA programs, high performance knowledge bases and rapid knowledge formation. I think Dave Gunning was the program manager. He's right here. They were fantastic programs. We developed all this technology to develop knowledge-rich systems. And when we put these systems in front of people, to understand how they worked and to use them, they had a lot of questions about where the knowledge came from. How is the system making decisions? And they didn't mean how was the algorithm of the logic of the system work. They meant how does the system have that knowledge? And so if we said, well, the general procedure comes from the Army Field Manual F5954, and actually was fine-tuned with some estimates from experts at, such and such place. They would say, oh, okay, that's all they needed to know. So I realized that for them, it was very important that we didn't just build intelligent systems, but that we were documenting the provenance of the information. And if you compound a lot of these decisions and a lot of systems that are where the information is flowing to end in some decision, the provenance of those decisions and how the information flows is very important. And we don't have good ways to track provenance of systems. We sometimes track them in individual systems, but not globally. The web is another good example, right? It's an open system, anybody can say anything, there's a lot of information out there. We don't know what to trust because there's not a whole lot of information about the provenance of what we look up. So we worked with the W3C to create a standard representation for provenance, and there's now hundreds of different systems and a lot of researchers in academia, but also a lot of companies in the commercial sector. They're also starting to adopt this standard. And what it means is that now we can have a constellation of systems that are involved in giving you a final decision, and we can actually track for every action or decision that the system made, or for every piece of information that it used, who was the responsible party, right? So who's the responsible entity? Is it a company? Is it the operator that ran that process? Is it the designers of that process? So you can start to document the entities and the decisions and the information that was used throughout this constellation of systems to reach to some final decision or result or data. And so tracking provenance across systems, I think, is a very key technology to this issue of accountability and eventually legal responsibility. It's an example of a good technological basis to address these hard questions about accountability.
But when we come to a machine learning system, say a deep learning system that for computer vision, it's much more difficult to try to figure out how we can say, well, here are the 500 images that were most similar to the one you just gave me. But interestingly, we don't expect people to be able to give an explanation either of, you know, how did you decide I was holding a glass in my hand? Well, because we can't explain it ourselves. So I think the expectations about what should be explainable and what aren't are pretty fluid.
I still think that's a good example, though, and we could ask for our systems to do more in that direction. And,
yes.
And that's one thing that I'm very excited about is the recent work many of us have been pursuing at the intersection of language and vision. We now have these systems that can be trainable to go from images to language. And a great use of that, I think, is to make systems seem more accountable or be explicitly more accountable. And at least to the same degree that a human could explain why that looks like a glass, I could say it's clear and sort of round and has liquid in it. I mean, maybe we can explicitly constrain our machines to make those same sorts of explanations. And for glass, it's not as compelling, but for a black-eared, double-billed woodpecker or whatever it is, there probably is a little story that the expert wants to tell you about. Oh, it's the coloration on the tail and its configuration or something. And I think if our machines also could output that, that's probably the most optimistic view, I think, for how deep learning algorithms could open their own black box, in a sense, by being explicitly trained to tell stories about why they are functioning.
And I think even if you cannot explain exactly how that black box of a certain algorithm worked, you can certainly say it was given this kind of training data, right? So this car was trained in all kinds of roads, all kinds of weather, all kinds of things. So you can actually document the context of,
yes.
of how that activity occurs,
I mean,
right?
We're in strong agreement in the sense that I think it's very desirable that these systems be able to explain themselves. And often that's important just for debugging them, even, because you can say when it makes a mistake, well, why did it make that mistake?
And I was going to say, I said before I have more fear of humans. So people actually explain away.
Yes.
They don't explain, they explain away. They make up a story about why they made a decision. And we see that a lot when you actually study and analyze human behavior. So the fact that humans say, I can explain a decision and I did it with all this, doesn't necessarily mean it was done following what they're explaining to you. So.
I mean, humans are terrible eyewitnesses as well, right? I mean, the computer's going to do much better than most humans.
So in kind of continuing this line of thought, that if you're able to have some piece of machine learning or whatever model you have there explain why it's making decision, explain why it's making the decision, maybe you can use that explaining aspect to reason about things that it can and cannot do, right? So being able to limit the set of inputs or characterize the set of inputs under which you agree with the decision, or the decision is actually going to be acceptable, as opposed to the set of inputs. And it's interesting that you brought up the lending. It's been shown that there's bias, right? So because there's bias in the data in terms of lending histories, there's also bias in these algorithms that bring out and people from underrepresented groups or people from lower social things that are not necessarily tied to the lend decision itself. It still biases against them. And you know, that's a fear, right? So that is a legitimate fear of moving the decision making to a fully autonomous, to a fully AI system without any human supervision or human in the loop. But once you can explain, once the lending software will tell you, you know it, because a lot of people in this neighborhood didn't get loans, then you shouldn't give this person a loan too, then you realize that's not necessarily the right, and then maybe you can kind of fix it.
And to be fair to them, they also, you know, it's no single thing. It's thousands of signals are used, so it isn't how you filled out the form. You know, because the one that's always the funny one is that, you know, how you fill out the online form. There's a slight correlation. If you fill it out all uppercase, you're worst. All lowercase, next. Proper case, best. And as the guy who was the CIO of Google said, who set up this, set up one of these, it's called Zest Finance, and it's Douglas Merrill is his name. He said, look, I can make up a story about why that's true, but I have no idea, right? And in fairness, it's one of, you know, a gazillion of these kinds of things that are used.
But interestingly, there has been some recent work. There's some interest in the machine learning community on fairness in machine learning. And there's some interesting research in which you say you want to have a loan application thing that does not discriminate on the basis of sex. So one thing you can do is first use all of those thousands of features that you have, the case of the letters or whatever, to predict the sex of the person. And then you can require that the informationally, the only information the computer can use is information that is independent of all that information that was used to predict sex. And so you can actually prove that the computer is not using sex in making its decision. And so I think we could actually, coming back to computers being maybe better decision makers than people, we could make computer systems that were provably not using race or sex or whatever constraints you wanted to put. You could give pretty strong guarantees that they weren't being used in making these decisions.
Yeah, and this gets back to, you know, originally Tim Berners-Lee talked about this trust layer, right, that we want to build in the web, which was what you're working on, and now he has this startup, actually, that goes by that name. But, you know, part of this is the social engineering side. I mean, in the sense, or simply the social side. I mean, there are some class of people that are petrified to get on an airplane. Statistically, it's much safer per mile than driving in a car, you know, all that kind of stuff. That isn't the answer. Or the design of the original Nest thermostat. When the first experiments with it, you know, they figured they'd take a few settings from the people and take over. The testing group hated it because they weren't in control. So they changed it so that you could constantly intervene all you want. People, you know, they put in a few settings. They saw it worked pretty well. That was fine. I mean, the inputs were exactly the same in a way, but there was a small design change, and it was as much behavioral as anything else that resulted in people saying, "Great, let them take over." And that's, I think, there's this whole kind of social side of this that, you know, is an element as well. But I think we can open this up to questions at this stage. Anybody, and there are, if you want to, because they're trying to record, so if you could go to the microphone and just identify yourself.
We have one.
Yeah, we do.
We have one from the app.
Yeah. It runs off the page a little bit quick.
Do you want to do that one first, or?
No, you're up there. Go
Okay.
ahead. Come on.
So I'm Larry Hunter. I'm from the University of Colorado. And it strikes me that we've danced around an important question that Nick Bostrom in his book really wrestled with hard, which is about values. And decision-making reflects a set of values. And so when you talk about the robot doing what you intended it to do, how do we make sure that the intentions are ones that we subscribe to? It's the same problem with other minds. So when we deal with other people, when Tom raised full autonomy, we shouldn't allow robots to have full autonomy. We don't allow people to have full autonomy. We have social constraints and legal constraints that keep me from running around naked or shooting people or doing other things that the society says, well, you don't really have the right to do that. So should we take seriously the idea of trying to build goals and evaluation of goals and values into AI systems? And how do you think we should do that?
Well, they will always have values, explicit or implicit. So it would be better if we were explicit about it, I think.
True,
So that would be the
how
first
do we build
starting
good
point.
ones, right? So we've all, Scripts, Plans, Goals, and Understanding, a classic AI book. We've gotten really good at the scripts part. We're pretty good at that. And planning systems are okay. But goal-based stuff and reasoning about goal-based things and explaining goal-based things. So when there's an autonomy issue, if a person does something that looks like it might have been a crime, we ask them to explain themselves. And we think about what we want as a society, what they wanted, what the explanation for the behavior was. We have this integrated way of making judgments about virtue and vice. And I think the AI community has kind of tried to dance away from having to think about that issue. And maybe what I hear as a background to a lot of your discussion so far is maybe we need to grapple a little harder with some of that.
Well, I'm going to sort of simulate Stuart Russell here. So one of the things Stuart is currently working on is precisely trying to have computers learn from studying movies and novels what is acceptable and unacceptable behavior. So this is maybe it's empirical ethics rather than ethics based on any principles. So his reasoning is that most interesting literature and movies and plays usually centers around some ethical conundrums and some behavior that was wrong, and either in the old days the bad guy would get punished, nowadays the bad guy gets away with it, or we don't know, and so we're left wondering. But he feels like this is a huge database that could be mined to understand what it is that within different sectors of society, different cultures, different countries is regarded as acceptable or unacceptable, and then the computer could use that to assess its own proposed behaviors and ask, well, are these things that if a person did them would be judged to be bad, right? It's sort of the opposite of the old definition we used to say of intelligence was if a person did it, would it be considered intelligent? So it's operationalizing acceptable behavior.
So I want to say that, let me talk a little bit with an example. So machine translation came up this morning, right? So we had a spin-off from USCISI where I work on machine translation, a commercial company, and their software was used to translate TripAdvisor reviews into other languages. So if they had not done this, no one's going to manually translate all these reviews. So that system has no values. The person that has the values is me, right? I look through these reviews and I have to make a judgment of whether I trust the reviews or whether I trust those translations or not. So recommending places to go in Spain, I was reading the review of a restaurant and it said, no es muy bueno para ajedrez. And ajedrez means chess. So it said, literally, this is not very good to play chess. And I was wondering why a restaurant would be judged upon that. And so I went to see the original review, and it actually misspelled cheese as chess. Okay, so machine translation systems are getting much, much better, right? 10 years ago, you wouldn't want to use one because they were completely at a loss. You could not understand what it was translating. Now you can sort of make something up. But you have to make a decision on whether you want to use a machine translation system to communicate with another human, given that mistakes like this will be made, right? So I think the values come from the user of those systems, and sometimes they're subjective. It's a judgment that you make on whether you use a technology for a certain purpose. Depends a lot on the purpose. So I think values may not necessarily be associated with the system, but maybe more with the socio-technical context of use, and the user has a judgment to make about whether they want to use that AI tool or not.
So just to follow up on Yolanda, so if we're following what Tom said this morning, is we're going to have systems that always have some human aspect, so some human influence, supervision, something like that. So once you have a system that's able to explain what it's doing as it's doing it, or if it has the ability for you to query it, oh, why did you do that? Then the values of the person are kind of intertwined in that system by that feedback mechanism, by stopping it, by saying, you know what, yes, you should not be driving on the left-hand side of the road if you're in this country or whatsoever. So the fact that we're not talking about something that's fully you wrote it, you created the system, you hit a button, and then you're never going to interact with it again, then that question becomes a little easier because there's always a feedback mechanism with the person.
Excellent. We have a question from the app. And it's highly, this is good. Was Asimov on the right track with high-level loss for AI, or will it necessarily be much more specific and granular?
Well, and I would interpret that as essentially the same question that Larry asked, which is, and the answer is much more specific and granular. I mean, Asimov's books were interesting precisely because he shows all the cases that break when you have only those 3 laws. And there's also been some interesting work published in the AI literature analyzing those laws and noting that some of them really cannot be computed. So there's another issue that sometimes we can for instance, right, Asimov's law requires that a robot have perfect foresight about whether an action it would take might injure a human, right? We know that's really not possible. So those laws are really unrealizable. You used the phrase humanly possible earlier today, and we use this somehow when we're thinking about what a reasonable person can anticipate is the kind of rule in court, I guess. But we don't know what that means for robots. What's a reasonable robot supposed to be able to anticipate?
Let's go to the other side.
So I'm Mark Wasser from the Digital Wisdom Institute. Centuries of discussion about Kant's categorical imperative have pretty much proved that you can always generate circumstances where a given action is bad. So that sort of makes it tough to believe that Stuart Russell's approach might work. On the other hand, maybe there's possible that you can come up with something. For instance, the social psychologists, Jonathan Haidt in particular, says that there actually is a categorical imperative, and it's his definition of the function of morality, which is to suppress personal selfishness and do what's necessary to live together cooperatively. Now, my question is, for Nick Bosterman and others, if that were the topmost goal for these goal-stacked machines, how could that possibly create a problem?
I think maybe I would come back to my previous point, which was that actually implementing that computationally might not be possible in all cases, right? Because it might require essentially, omniscient or complete inference, or working out all the possibilities, and it would be like completely solving chess. It would require,
I think it would be possible in those cases where the machine could make mistakes, certainly, but you certainly wouldn't end up with the evil robot overlords that so many people are very fearful of. I mean, we'll always have mistakes. You can't predict the future well enough. But if you do put that as the topmost goal, do you foresee some way in which that can go horribly wrong? As you see similar Asimov's rules can very often go horribly wrong.
Well, I think a lot of it comes down to the unknown unknowns. I mean, for instance, we're wiping out the chimpanzees. That's not really our goal. It's not a deliberate thing we're doing. It's just that we've been reproducing and occupying more and more of the habitat, and eventually the chimps, the orangutans, and so on, there's not going to be anything left for them. So if we are aware of that, but you could imagine that a robot might be unaware of some side effects of some action it's doing. So it doesn't realize that when it drives on the left or something, that's running over pedestrians, or who knows what it is. That's unlikely. But some side effect of some action it's doing turns out to be catastrophic. And I think in my thinking about unknown unknowns, this is another place where I think computers might even, the rational response to the fact that we don't know all the effects of our actions is that we might become superstitious. We take an action and we see something bad happen, we say, oh, maybe I caused that. Maybe I better not ever try that action again. It was such a terrible thing that I just did. That, and it could be that that's actually a rational response. So our robots might become superstitious when they try to not cause harm.
Thank you. Let's take on the left.
Hi, I'm Scott Navani from BBN Technologies. I appreciated your discussion on interpretability, And in my line of work in natural language processing, I often find that the best methods are often the least interpretable. And so I wonder if you have an opinion on how much interpretation is worth the loss in accuracy, and if you even agree that it's a trade-off to begin with.
I would say.
Can you repeat the question?
Repeat the question?
I think people could.
Sorry?
Repeat the question.
Oh, okay. I think you were asking about how, in your work in natural language processing, sometimes if you want explainability, then the methods have less accuracy, and so it's a trade-off that you grapple with. So I think it's a reality that sometimes you trade off explainability for accuracy or for performance. So I think the decision makes on this decision hinges on the applications that you have in mind or the context for these systems. So you may not be able to have both, or you may be able to do some form of. One of my early papers was on automated rationalization. So you compute very efficiently in a way that's unexplainable. And then if somebody asks for an explanation, you go through a much more deliberative process of explaining away why it could be that that decision was made by this extremely efficient but very black box kind of system. So
I think I think it's a trade-off it's worth trading off some of the optimality for the explainability when you're talking about systems that interact with people, because even if it's not optimal to the nth order, being able to reason about having some trust in the system that it did something in a way that I can understand why, it's worth a lot more than the extra. Again, of course, it's application dependent, task dependent, domain dependent, and all that. But if anything, if it's within the realm of a system working with a human, then explainability is, I think, is to some extent more important.
But we haven't really talked about the fidelity of the explanation and what does that mean? What does it mean for the explanation itself to be correct? So I've also had this experience in machine learning systems where we give an explanation, but it's really only an approximate explanation. And often that's enough for the person. I mean, you were sort of saying the same thing, and Trevor was too. Enough for the person to be able to judge whether the thing was correct, even though we haven't gone into all the little tiny nuances and all of the extra cases that were checked and discarded and so on. And so you can imagine there's a whole spectrum here, and how should we evaluate the fidelity of the explanations is a really tough question.
Thank you.
Hi, my name is Michelle Fry. I'm from Hope Behavioral Health. I work in the mental health community, and I deal with attachment disorders, with PTSD and different traumas. I also ran robotics for Northeast Ohio, so I do it metal and emotions, the two mix. I have two questions if I have the time, and if I don't, I understand. One is dealing with the here and now, with psychological fallout with attachments to autonomous robotics, especially if they're in our home, which we have seen with soldiers who become attached to robots that get blown up by landmines. They have an emotional response to that robot, which has no feeling. So imagine if then they do have feelings. So that is one of my questions I would like to expound upon. The other one is future progressions. If we have future progressions, let's say within the next 100 years, and the 3D chip becomes reality, there is something as emergent behavior, and going to the positive of emergent behavior, not the bad side of emergent behavior, which is a possibility. I would like to address that. But the first question is there any research being done in the psychological community about attachment to anthropomorphic robots, no matter what they look like? It doesn't necessarily have to look like us. It can look like a mining robot, and obviously there's an attachment. What research is being done, and how are we going to prepare the general public so we don't have emotional crisis?
So there's a field within robotics called human-robot interaction, and some of the research done there. I'm not an expert in that field, but some of the research done there is on the way people interact and the way people emotionally respond to robots. There was actually one study out of, I believe, a professor in Germany that had people destroy robots. Yes. And see what happened with that, right? So those created really,
But it came back that the people were highly upset.
Yeah, because they felt they interacted with the robot and they had to destroy it. So it's a little bit like a pet, right? It's not. So yes, there's a big field in robotics.
But that's the only research that I'm familiar with. Is there more?
There's research, again, not an expert in that field, but there's research on the interaction between humans and robots with the different contexts. That was an extreme thing. I don't think that would pass IRB in the United States. I don't think you'd be able to do that, that kind of research in the States. But there are other things that are less extreme in terms of how do people interact with robots? How do autistic kids interact with robots, and how that helps them improve and learn social skills and all that. So there's a big body of research, and it's kind of a growing field, looking into those questions.
A good keyword to search for is social robotics. Mm-hmm. There's a journal on social robotics, and those are exactly the kinds of issues that they study. And humans behave very strangely around robots, I have to say. Surprisingly strangely.
Yes. Hello, my name is Michael Wolowski. I'm from Rose-Hulman Institute of Technology in Terre Haute, Indiana. I have a question about related to the article that was in the New York Times the other day about the Google self-driving cars being involved in accidents. So, and it's a legal sort of question, I guess. Apparently, they follow the rules much more closely than human drivers, yet they're a menace to the California drivers there. So, does that mean that we need to build cars that don't follow the rules as closely? In other words, some illegal drivers, if you wish?
Well, so are the cars really a menace? But it's more, I think, that humans either exploit them by pulling in front of them because they know they'll stop, or rear-ending them because they don't expect them. They expect them to be more human, behave more like humans. I mean, I think it's a very interesting question. We were discussing it a little bit last night because of course, the current designs for self-driving cars are very conservative. They're going to obey the law, and it could be that will make them unacceptable to customers, right? Yeah. Because there is a game theoretic competitive aspect to sharing the road, in which we're competing for this scarce resource, and so yeah, it is an interesting question if there's going to be like an aggressiveness dial that you dial up because you're not able to merge onto this thing because people keep cutting in front of you forever, right? I mean, in computer science, we call that starvation, and so that could happen. Then the question I think is interesting is, okay, who is liable when there is an accident?
I mean, who's going to sign off on that thing?
Directly linked to Progressive's box. You can dial up all you want, and your rate goes up for the month, right? Exactly.
Yeah, maybe.
No, but isn't that some sort of like, I mean, you can't just build cars that violate laws, right? I mean, can you do that?
No, but if all cars are self-driving cars, there will be no accidents.
Well, that's one solution.
Right. Thank you.
Go ahead.
Hello. Indeed, sapiens plurum. Can't even say your name. I'm interested in the fact that everything we're talking about is constraining AI and constraining robotics, and really isn't part of the issue a lack of our ability to actually productively use all the productivity gains that we're creating, not just with AI, but with all our technologies. And the issue is, in the old days, you improved a computer, and so a secretary lost her job, and she had to learn how to use computer graphics or some other sort of office software. Well, now, we saw this morning, we're going to be replacing sportscasters, you know. We're going to be replacing the person who's doing the computer design, and we're going to be replacing taxi drivers. So this taxi driver, though, he can't just go out and learn to drive a different kind of taxi. He's got to figure out how to buy 100 taxis, self-driving taxis, and use them to create a delivery company. That's a whole different level of skill. So because suddenly he's 1,000 times more powerful than he used to be. So if we're all 1,000 times more powerful, if we can do 1,000 times more things than we could, we have to change the way we dream and change the way we imagine and change our expectations of ourselves and our society and our lives. And we don't hear too many people talking about that.
I think that's a great point. And one of the things that I hope will change a lot is how we study human behavior, right? So all of these issues that we've been talking about have to do with how we understand human-computer interaction. And human-computer interaction experiments and evaluations are very costly. There's a lot of personal factors involved. It's very hard to make those studies. But as we progress forward, I think, and we have a lot more data about how humans behave with technology, look at our phones and how much data we can capture, as we have more cameras looking at how we interact with robots, and we start to get a lot more data about human behavior, maybe we can have better models of how humans interact with technology, what kinds of modes of interaction we prefer, what aspects of intelligence or technology is more amenable to make us more capable or actually hinder our capabilities. I think this area of understanding and modeling human versus machine might change a lot as we collect more data.
I'm afraid we've run over our time. So I'd just like to thank the panelists and thank you all. Appreciate it.